Good day and welcome once again to the collections of the Tate Geological Museum here at Casper College in Wyoming. And once again we are doing a presentation about marine reptiles in lieu of our conference. We weren't able to have our field conference because of the epidemic, and so instead we're giving you a special behind-the-scenes look at the Tate's marine reptile fossils with our collections manager, J.P. Cavicelli.
Good day.
So, our first episode dealt with plesiosaurs. The second one dealt with mosasaurs. What is the name of the genus of mosasaur that we looked at last time?
We told you it'd be on the test.
Yeah, and they thought I was just bluffing. It's Plioplatycarpus. All right, give yourself extra points if you got that.
And if you didn't, yeah, it'll be on the next test again.
Yes. Now, what are we looking at this time, JP?
Okay, so we have a collection of random reptiles today.
The odds and sods of the Jurassic.
Yeah, the odds and sods. Let's start with this guy.
All
That's
right.
Not a dolphin, although it looks like one, but this is a reptile called an ichthyosaur. And we have a few specimens of these things. I guess you already did one of these shows about the one that's out in the skull we have.
Yep, but our viewers did not see this fossil right
one.
here, which
This
I'm
is
assuming is ichthyosaur,
An
right?
ichthyosaur.
Okay.
Can you guys see it okay from there?
All right, now this is much more complete than the ones that I showed to my viewers. They just looked like a row of hockey pucks. It was nothing but the centra. And here, though, we've got more on there.
So, and we've got, what, 5 of them lined up in a row?
Nice.
5 vertebrae. And then a pile of ribs kind of going this way, that way.
So is this part of the vertebra as well? Right in
Yes, it is. Let me see what I'm looking at. Yes.
there? So this is upside up.
This is upside up. So
Okay.
we're looking at the centrum is this part here, the centrum being the round part of the vertebra. And the sticky out parts are the parts that are going in here. Now, if we had taken these ribs out, we may be able to see more of the vertebrae, but we chose not to because it kind of looks cool as a pile of bones like that.
Oh, yeah. Yeah, I like it like this.
This is a fairly small individual. I would say, God, I don't know, 12 feet long maybe?
Okay.
That's a random guess. These things got to be up to 40.
Yeah,
40
there's
feet long.
a specimen in the annex that has centra that are as big around as a personal pizza. I mean, they're big.
And not quite as delicious.
So this guy, 12 feet, you say?
That's what.
So
yes.
like pilot whale sized, or maybe smaller,
or a large dolphin.
Oh, or a beluga.
Oh, everyone knows how big a beluga is.
Right.
Um,
Now, in dinosaurs, these bits here fuse onto the centra when the animal's fully adult. Does that happen in ichthyosaurs too?
I don't think so. But we saw the same thing in the plesiosaur 2 episodes ago.
Yeah.
Where these sticky out bits actually fused up onto the, well, boy, I'm using the word sticky out bits all over the place. Where the rib attachments kind of moved up onto the neural spine, which is what I usually call the sticky up bits. So, what else was I going to say about this guy? This guy is Jurassic, about 180 million years old, found north of Casper here. We have a few other pieces of this one, but we did not find the head on this one, which almost makes sense because these things have a lot of ribs, a lot of vertebrae, and only one head.
Only one head, yes, unless it's a freak.
So that's our quick ichthyosaur.
That was cool.
What else we got? We got this one down here is pretty special, I think.
Okay. So
look...
these both belong to the same sort of animal?
Yes, they do.
All right.
This doesn't look like much.
All right.
It's a vertebra. We can tell that because it's got round ends over here and it's got sticky out things going in 4 different directions in this case.
Now here's what I'm noticing.
Yeah.
We had our plesiosaur with the flat ends to the centra. We had the ball and socket arrangement with our mosasaurs. Now this one is concave on both sides.
Notice how my fingernail disappears into the bone. There's a hole.
Stop doing that. You're making me nervous.
I'm a trained professional. Do not do this at home.
Okay, do not do this at home. So what sort of beastie does this come from?
We are pretty sure that this is a marine crocodile, which is actually really cool because A, they're rare, B, I don't think there's any others known from Wyoming.
Awesome.
These were actually found by folks up in northeast Wyoming who were doing a survey for a future, I think, uranium mine or something. I'm not sure what, but they found one vertebra, and another team found these bits and pieces, which are fairly nondescript, except that they have these beautiful round holes in them. These are separate bones, and you see the round holes in there. When you see round holes on flat bones, 98% chance that they are crocodiles, unless you get back in the Triassic, but we don't have much Triassic here.
Right.
So these are crocodile scutes. These are the skin bones. They come from, they actually live inside the skin of the crocodile, and they give it armored protection, basically.
Okay, and you said this is Cretaceous.
This is Cretaceous, late
Okay.
Cretaceous.
All right.
So
this would have still had armor. It's
Yeah.
an ocean-going crocodile, but it's still got armor in
Yep.
it, so
And
it's not too specialized that way.
no, it's not too specialized, but it is, as far as I know, this is the only marine crocodiles from Wyoming, and a few other samples we have in the back room that are even less visually appealing.
Well, that's super cool.
Yeah. So someday, maybe we'll go get a chance to look for more of these things. Maybe. So that's the crocodile portion of our program today.
We hope you've enjoyed it.
And now we're going to move on to the flying reptiles. While they're not technically marine, meaning they don't live in the ocean, pterosaurs, flying reptiles, are most often found in the same beds where you find marine reptiles, be they Jurassic or Cretaceous.
So we can see these living a lifestyle kind of like a modern seagull, gliding over the
Yeah.
ocean, grabbing fish, and occasionally dying, sinking to the bottom, and getting mixed in with marine reptile bones down there in the mud.
Unfortunately, we don't have many bones of these things here at the Tate, but that's okay because we have footprints galore.
Which brings us to this specimen
It does,
right here.
indeed.
Yes, indeed. Alrighty.
So what
So
we're
what have we
looking
got
at
here?
here is a...
It's
Can you see it okay? up
Closer to
there?
my end. All right.
There are footprints of pterodactyls.
And note,
Russell?
we've got 1, 2, 3, 4 toe marks there. So that, he says, holding up 3 fingers, 4 toe marks. So this is a creature that has 4 toes on the hind foot, which is the standard issue number for the pterosaurs, for the flying reptiles.
And he's also got, if you look back here, that's his heel mark. It's going off the rock, but that's his heel going back there. There's another set of 4 toes going over here, which has the heel is way over here. There's a footprint. On top of that is a slightly smaller one with 1, 2, 3, 4. Those are footprints. There's another one down there. There's a faint one right here, I like to think. There's, oh, what's this, Russell?
That's a very good question, yes. Here we're looking at a print of 3 digits. An inner digit right there, a second, and then a long digit coming back. Now 3 is the number of fingers coming off the leading edge of the wing of the pterosaur right there. The leading edge of the outer portion of the wing is actually digit number 4, and they don't have a pinky finger at all. It's just gone.
Oh,
Yeah.
so it's this finger? Oh, I
Well,
can't
yeah,
remember that
the
one.
4th finger, right? The ring finger,
Yeah.
And
Right.
Dr. Bacher pointed out to me years ago that finger bone is actually bigger around than the animal's thigh. So they're really, really committed to an aerial existence. Flapping was more important than walking if
Yeah.
you're a pterosaur. So this would be folded up up and back out of the way like a ski pole. As if I know.
ski pole.
Right. And then the 3 fingers would be walked on while it's on the ground with the thumb here. And then this finger number, where am I? 3, pointing back. So that footprint, or handprint, this handprint was made by a pterosaur that was crawling along in that direction.
Cool. Now the
thought
other
so.
cool thing about this specimen is that it's also got raindrop impressions.
I was going to ask about that.
And that's what the little round circles you can see. And for a long time, these pterodactyl footprints were argued to be crocodile swimming marks, where the crocodiles would be swimming underwater and kind of scraping along the bottom. No.
No. So too bad. I can't think of a crocodile, any crocodile, living or extinct, that has a 3-fingered hand. So
Yeah.
I'm going to dismiss
So,
this out of
The
hand.
fact that we found these ones that have raindrop impressions suggests that the raindrops and the crocodiles look at me, I'm making mistakes. The raindrops and the pterosaurs were walking. Let me explain how raindrops walk. The raindrop impressions and the pterodactyl impressions were all made on the same surface that was not underwater, but that the water had receded out of and was kind of a little muddy shore, if you will.
So this really kind of paints a picture. We're looking at a
Yeah.
wet beach, a gloomy overcast day, and our little pterosaur walking along in the mud with raindrops falling on his head. Yeah.
Is there a song there?
Why, there could be. I'll get
Should we
back
go
to
out
you
with
on
the
that. Let's not.
Let's not.
They've suffered long enough.
So
Well,
that's our. Is that our show for today?
That's
You're the
our show
boss.
for today. Thank you guys very much for joining us. And next year, we hope to see you in person at the Tate Field Conference.
Which will again be on marine reptiles.
Mm-hmm.
Thanks for coming.